Okay, for example number 2, straight away we're going to see an application of this diagonal force rule. So here we've got a box, it's being pulled along by a 10 Newton string, but it's lying at 30 degrees to the horizontal, and it's asking about acceleration of the box. So straight away we know from our year 12 work that this is going to be force equals mass times acceleration, with the added complication that it's going at an angle. So what we do first is we label our diagram with all the forces. So we know that this is going to be 8g, the weight of it pulling down, and we know that there will be a reaction force from the table. And what we're going to do firstly to calculate the acceleration, right, we're going to accelerate in this direction to the right. So what I'm going to do is I'm going to put a little right arrow here. That tells us that we're having a look at the forces that go in the direction to the right. It also tells us that right is going to be the positive direction. So the force that goes to the right is the 10, but it doesn't go straight to the right, so we need either cos 30 or sine 30. And again, the way that we know that is that to get from 30 down to the horizontal, you've gone through the angle, and if you go through the angle, it's going to be cos. So it's 10 cos 30. Okay, and we can work that out, but actually we don't need to in this situation. We can just put it straight in. So F equals mass times acceleration. So 10 cos 30 equals 8a, and then we divide by 8, and we will get the answer for A. So this is 1.08. And again, just like always in mechanics, we're giving our answers to 3 significant figures. So that's the level of the acceleration. To calculate the part B, right, that's obviously answer to part A. For part B, all we're going to have to do is calculate the normal reaction between the box and the floor. So we're going to resolve in the vertical direction. Right? And in year 12 you just have 2 forces generally, you'd have the R and the 8G balancing. But actually this 10 newtons is going to affect it, because if we're pulling and we've got a force pulling it up off the table slightly, what you're doing is you're taking pressure off the table. So when we do this, we'll take the up as the positive, that's what the up arrow means, and we'll have R in the up direction, but also helping the R on the same side, also pulling up, is this 10 Newton force. But again, it's not directly up, so we have to consider whether we would move through the angle or away from the angle. So to get to the vertical, because we're resolving vertically, we would go away from this angle. And if it's away, we use sine of the angle. So it's R plus 10 sine theta. And then because we know the box isn't going to take off, right, the reaction force is going to keep it flat on the table, it's not going to sink through the table, it's not going to jump off into the air, we know that's got to balance with the weight. We know it's equal to 8g. So then we just rearrange, and R will be equal to 8g minus 10 sine 30. Pop it into your calculator and give the answer to 3 significant figures. Okay, so this is R equals 83.4 newtons.